Hello everybody, it's Mr. Veale again here, and I am the head teacher of Atwood Primary Academy, which is situated in Sanderstead in South Croydon. And today is Monday the 18th of May 2020, and this is my next in my series of Head Teacher Lockdown Vlogs. I hope that you really enjoyed your weekend, whatever you got up to. We decided that on Sunday to go and have breakfast on the beach in Whitstable. We decided to set our alarms really early, even though it was the weekend, and then pack up some equipment and then go down to the beach. And then I've got a little camping stove, and I cooked breakfast for my wife and the children on the beach, and they enjoyed cycling up and down and paddling in the water, although the water was pretty cold. So we had a very enjoyable breakfast, and then we were very aware that maybe the beach could get quite busy, so we decided to come back to our house at about 10:30 in the morning, and then spend the rest of the day playing in the garden. And we decided it would be fun to set up a crazy golf course on our lawn. And so we spent much of the afternoon not only setting up our crazy golf course with all sorts of weird and wonderful objects and barriers and so on to get through, but we spent a lot of time playing crazy golf, which we had a really good time. I'm hoping that everybody's keeping okay at home. Just to say, as head teacher, I know myself and all the other members of staff are really missing you, and school is not the same without children. It can never be the same, but I know that for some of you might be looking forward to, if we're still able to open on the earliest date, which is the 1st of June, to coming back to Atwood. But I know a lot of you will be continuing to do your home learning at home, so we still got to face up to the realities of what that's going to look like, having some children in school and then having some children obviously at home. I know that my senior leadership team, we've had a long discussion with our wonderful teachers about moving from my USO over to Google Classrooms, really to make sure that how you learn at home is a little bit more engaging and a bit more interactive with your teachers. So watch this space and we'll see how that goes. Now, it wasn't particularly windy down at the beach yesterday, but I know we have an awful lot of people who love to go kite surfing in Whitstable. It's quite famous for kite surfing, but it's also just very popular to fly a kite. And I was wondering whether I could say to you about making some sort of kite at home. And this one here has been taken from Science and Nature, and it is on page 32-33 here. So here we go, building a kite, things to make and do. So it says here, aim for the sky and turn a piece of paper into a soaring kite. So listen in everybody, because here is what you're going to need. You're going to need one piece of A4 paper. You're going to need a ruler, a pencil, a stapler, some scissors, some sticky tape, a hole punch and some light string, and it says in brackets here about 6 meters. So here are some instructions, so listen in guys. Take a piece of A4 paper and fold it in half. Step 2, using a ruler, measure 5 centimeters from one edge on the folded side and mark a small dot. Number 3, measure another 5 centimeters further along from the first dot and mark a second dot. Number 4, fold over the left-hand corner to touch the first dot. Hold in place, but do not make a crease. Repeat on the other side for step 5. Pinch the corners together at the first dot and staple them together. Number 6, cut a length of sticky tape. Stick it over the crease to cover the second dot on both sides of the paper. Number 7, ask an adult to help you punch a hole using a hole punch on the second dot. Number 8, thread one end of the string through the hole and then tie a knot to secure it. Number 9, Tie the other end of the string to a pencil. Wrap the string round the pencil and you are ready to fly. So here we go. How does it work? Well, there's obviously some science here, isn't there? There are 4 forces at work on any object in flight. Lift is the upward force that keeps your kite in the air. This is created when air moves across the special shape of a wing. Lift counteracts the opposing force of gravity. This downward force, created by the gravitational pull of the planet, wants to keep your kite on the ground. To fly, the lift force needs to be equal to or greater than gravity. When lift is greater than gravity, your kite will rise. When you pull the kite forward using the string, you generate a forward-acting force called thrust. Its evil twin is called drag. This backward-acting force slows the kite down and is mostly caused by friction when air moves across the kite. And here's a last fact for everybody. Let's go fly a kite. Did you know that the largest kite ever flown was 25.47 meters long and 40 meters wide? That's about as big as 4 tennis courts. The record was set in Kuwait in 2005. So things to make and do: making an A4 piece of paper kite. Well done, everybody. Now, while we were having our breakfast on the beach, it was very clear, and so on a clear day you can look right out into the Thames estuary and you can see a lot of wind farms busily generating electricity. And there's one off the coast of Whitstable, and then there's one further along just off the coast of Margate, and then I believe there are ones that are much further north into the Thames estuary, probably hugging the Essex coast. And one of my children said to me, well, how do they work then? How do they turn wind into electricity? So I thought I would have a go at answering this question, and then I decided it was getting a little bit too complicated for me. So I thought, well, do you know what? I'll do some research. So here we go. I found in Science and Nature again a section called Head Scratchers. So here we go. And it says here, here's the question: how does wind get turned into electricity? And you can see an absolutely wonderful picture there of inside one of the wind turbines that are out at sea. So to turn wind into electricity, you're going to need a wind turbine. This works like a giant electric fan, but in reverse. A fan uses electricity to make its blades turn, and they then make the air move. Well, a wind turbine uses air, or wind, to turn its blades, which then makes electricity. The blades are connected to a gearbox, which is connected to a generator, which is a device that converts movement into electrical power. The generator spins magnets inside coils of metal wire. A moving magnetic field, the region around a magnet where the magnetic object feels a push or a pull force, has a startling effect. It has the power to make electrons, which are negatively charged particles, move inside wire of conducting metals. Movement of electrons is known as electricity, and this process is called electromagnetic induction. It was discovered by Michael Faraday at the Royal Institution in 1831 and is used today in every single electric motor or generator. So there we go. We're turning one form of energy into another. So clean power. Wind energy provided 20% of the UK's electricity last year. So that was enough for 12 million homes. And you can see in this wonderful diagram or picture here, we've got the generator where the electricity is being made. We've got that gearbox that presumably turns this rotary motion into some sort of other rotary motion, but going across a different, what we call a different plane, a different angle. And then we've got our blades again. So a wonderful thing. So I think I'm a little bit more confident, I hope, in telling my children how the wind farms work. Now I wonder at home whether you have got any other safe and clean ways that you're producing energy. I'm thinking on a sunny day, perhaps some of you on your houses have got solar panels, so we're turning light energy into electricity. I know at Atwood we have been generating our own electricity for about 5 years now, and that is because on a lot of the roofs here at Atwood we've got wonderful solar panels. So we are doing our bit to make sure that our carbon footprint is as low as possible. So there we go, wind farms. Okay, and now we've got a little bit of a puzzle section to today's vlog. So I'm going to try and hold it up here for you. And again, it is courtesy of Science and Nature magazine. And I'm going to talk through the maths mesh bit. This is all a bit strange. I can pop out from behind here. So it says, enter the missing numbers 1 to 9 in the blank squares to make each calculation correct. The calculations are worked out left to right and top to bottom, rather than calculated in strict mathematical order. So have a look at the maths mesh. If I hold it here, you can always grab a pen and take some notes on that. If not, you could always rewind this section of our vlog. And then I've got some anagrams for you, and these anagrams, hello there, are all environmental terms. So can you unscramble them? So C-A-L-M-T-I-E, that was C-A-L-M-T-I-E. The next one was mop cost, M-O-P-C-O-S-T. And then the last one, environmental terms, Widefill, W-I-D-E-F-I-L. And so that was Puzzle Corner. Okay, I just wanted to say a huge thank you to everybody. I know this is really difficult at this time of year, but I'm so proud of everybody, what they're doing, whether it's learning at home or coming into school or keeping each other safe at home, remembering those small acts of kindness. It's absolutely wonderful, and it just makes me every week even prouder to become and be your head teacher. So until our next head teacher lockdown vlog, I'm going to say, as I normally do, stay safe and stay bright, and I'll catch you later. Take care.